All right, thanks a lot. Can you guys hear me in the back? Yes, no, maybe? All right. As you said, I'm a mathematician, so I'm going to try to abstract this as much as possible. Sorry about that. My talk is not going to be about specific application. I want to give you a general idea of what big data is, or better yet, what big data is to me, and then maybe some tools that people use nowadays, and at the end, we'll close it by what is the connection with economics and applied economics in general. So, let's start first with what is not big data. And I've seen this a lot, not today at least, but in general I've seen this a lot. So it's not big Excel sheets, okay? If you see that, if somebody says I have an Excel sheet that has 5,000 rows, no. Database that can be analyzed by a personal computer, no, that's still in the realm of smallish data, all right? We're talking about servers here. We're talking about, big computers. Finally, it's not a database that you could just upload to the internet, all right? These databases may take days to download and upload. As a matter of fact, for instance, we are working with the Mimic database. Mimic database is a health informatics database. It took us 3.5 hours on one of the fastest supercomputers in the South Florida area to just download it, okay? So we're talking about these kinds of things as big data. So what is big data really? You will always hear the 4 V's in this area, so why not just talk about these 4 V's a little bit? Volume. Okay, that's easy. We know a lot of things. We know a little bit about a lot of things. For instance, Amazon, transactions per day, e-commerce in general, okay? You don't know everything about the buyer, but you know that he bought this, and there are like thousands of buyers per day. As a matter of fact, for Amazon specifically, there are 25 million transactions per day. So we're talking about crazy numbers right there. Variety. We heard about a lot of these things in the morning when you have, again, a lot of things about a medium number of things, but they're different, okay? So you know a little bit about weather. You know a little bit about, the enumerators, as you called them earlier on. You know a little bit about demographic data, so you have to somehow put them all together. That goes under variety. Veracity is one that I like a lot. You're getting information, but you don't know if some of it is right, if it's wrong, what's going on exactly. There are some hidden parts. For instance, if you're working with health informatics data, you don't know a lot about the patient. You know maybe when he went to the hospital, you don't know enough about him to make a general picture and make sure that everything you get is correct. Also, the volume. The volume is one of the areas that I'm working on. Sorry, the velocity is one of the areas that I'm working on. Velocity, what does that mean? Basically, you're getting a lot of data online, and they're coming in fast. We're talking about gigabytes of data coming in within 5 minutes. And you have to analyze it soon, otherwise it's not worth it anymore. Stock price analysis, for instance. People are fighting over seconds over there. Like if you can make a prediction based on what you're seeing here, you can make big profits. Or even when you're getting the health indices of a patient, if you see somebody going into some sort of heart attack mode, you have to act on that now, or else in 5 minutes, well, you may have lost the patient already. Who cares? All right, so velocity is one of those important things that people need to care about when we're talking about big data. All right, so the most important V, which you may not see a lot, is value. And I think this is one that will resonate a lot with the economists here, right? It's not big data for the sake of big data. It's actually what we can get out of it, all right? How can we make it work? What is in my data? What can we do now with it? All right? If you're just creating it for scientific reasons, it's great, but do the stakeholders care about it? All right? So that's the top priority for us. Whatever comes out of big data needs to affect a decision. Otherwise, why are you even trying? And as a matter of fact, all these processes are not cheap. Hosting things in a data farm is a lot of thousands of dollars per second. All right? Analyzing things, cloud computing is now cheap, relatively, but still, it's expensive. For instance, an individual cannot afford Amazon's cloud computing for a day. All right? Finally, whatever you get out of the analysis should be at least quantifiable. All right? Can I show some progress by using big data? If yes, keep it. If no, Again, why are you doing this? All right, so there are 4 V's, but I want to make the point that the 5th V value is the most important one. All right? Okay, my favorite quote from Grindrod's book is the following: big data analytics is not a way to turn 1 kilogram of data into 1 kilogram of PowerPoint, all right? And you'll see that a lot. You'll see that a lot because what's going on here is you have an analyst that knows a lot of methods and has this huge data set. He or she is going to try to cover all possible cases. And that's definitely not what we're trying to do here. Okay, big data, at least for me, is to find that one little trend that's hidden into this big mess, act upon it, get congratulated and patted in the back by your boss, and move to the next one. All right? So once again, value, value, value. All right? Okay, why big data, though? All right, why do we get to this big buzzword? Now, go back 40 years. 40 years, there was what we call the data scarcity. Whatever data you would get was a specialized survey, maybe done by the government, maybe done by your university. You had like, I don't know, 100 people in it, 1,000 people if you're, if you had a lot of money, and that was it. And you created all sorts of beautiful models out there, statistical models. You checked for everything. You came up with a nice hypothesis. You checked it. Everybody was great. Today, there's a different reality. Today, we have the big data reality. And here I have some numbers to basically scare you into believing that what I'm talking about is true. For instance, there are 300 hours of video uploaded to YouTube every second. So every second, YouTube becomes bigger by 300 hours of video. Or there is 1 petabyte of data. Petabyte is a million of gigabytes, right? 1 petabyte of data created by the Hadron Collider every day. Okay, and that has to be analyzed. Or, as I said before, 26 million transactions per day at Amazon, which basically Amazon keeps track of. Every time you hear buyers that bought this also bought that, that comes from crunching those 26 million transactions a day. Right? 500 million pictures per day on Instagram. Okay, that's obvious, right? And again, let me point out something here in the value section, and that's going to be a social experiment for you too. Imagine how many pictures are you taking more today that you have a smartphone than what you used to do 40 years ago. 40 years ago, you would make albums of your vacations, right? Because you had this camera recorder, had like 26 shots, that was it. You were planning your shots, you couldn't take like 4 or 5 of the, Eiffel Tower or something. Nowadays, you take 30. Yeah, which one of those is the best one? Why don't you make albums anymore? Think about these things. Because again, the value comes in. You have so many now that you can't find that great one. Maybe that's another point that you can apply big data in your life. Also, 6,000 tweets per second. That's an incredible number, especially if you think about it as 500 million tweets per day. Now, I'm saying this at the very end because one of the projects that I'm working on actually collects tweets per day. And we're collecting 8,000 tweets per 10 minutes, downloading them and analyzing them. 8,000 tweets per minute. That's the type of data that I'm working on. And you understand, again, if you're trying to do some sort of trend analysis that is based on an hourly basis, we're talking about 80,000 tweets per hour. And once again, if you don't analyze it, okay, within the next hour or so, it doesn't matter anymore. Okay? So that's the type of big data that I am working on. That's the type of big data that, the science has been trying to analyze nowadays. So that's big data. What is big knowledge? The second part of my talk. As you can understand, the standard model, which again, here I'm oversimplifying. The standard model used to be you have a subject matter expert that asks a question, maybe even provides a data set, and then you have an analyst, maybe a graduate student most of the times, that prepares the data, right, designs the experiment, creates a model, and then both of them sit down together, answer the question, and evaluate the process, right? That sounds like more or less what we do at universities. Well, you can understand that with 80,000 tweets per hour, that's not very, very possible. So I'd like to switch your perspective and present to you the big data model. The big data model works the other way around. So data is coming in, or it's collected somehow, and that is done probably in a data warehouse by the IT, which basically don't know what they're collecting. They're just putting in data and increasing their farm and increasing their budget. And then here comes the analyst. But then again, the analyst doesn't know what sort of data he's crunching. The only thing he can do is do stuff like clustering, trend analysis, machine learning that we heard earlier on, and I'll touch upon in a second, and outlier detection. All sorts of tools are created here, commercially available, SAS, SPSS, even non-proprietary ones. Torch is another one. Machine learning is the big buzzword here. But then what you need is the subject matter expert. So notice that he now comes at the very end. The analyst presents to him the cluster and says, okay, what am I looking at now? What does that outlier mean? Okay? But then together they have to ask the right questions. After you get the trend analysis, then you explain what the trend means. All right, so that's the little bit of a shift here. I don't know if you noticed. So I talked about new tools that are needed, and I'm going to outline two of them, the support vector machines and neural networks and deep learning. Now, these are like big words. Don't worry about it too much. Support vector machines is, now that we have so many data sets, and some of them are annotated as good versus bad, instead of us creating a sample, instead we'll let the data tells us which are the good values and which are the bad values. And if we have somehow a way to cut that out with maybe a hyperplane, here you just see a line, then maybe any other data that comes in, if it falls on the left of the line is good, if it falls on the right of the line is bad, or something like that. Okay? So that's one main technique nowadays of clustering basically in a yes or no question. And if you think that that's not important, it's one of the most highly used methods in big data where you have to make a decision immediately. Is this transaction fraudulent, or is it okay, turns out it's legal? For instance, somebody comes in, buys something in Hawaii. Did he really buy it in Hawaii? Is this the trend? Or if I went in and bought, women's cosmetics, it wouldn't look very well, right? So there should be a system immediately that picks that up. That's the support vector machines. The second one is the neural networks. Again, a big buzzword. I don't want you to be threatened by that one. You have used neural networks, a lot of you, if you've done logistic regressions. Logistic regression is a neural network with one node. Basically, the different layers are, you put various nodes, you have hidden variables at each layer, and every one is some sort of function of the previous variables. You allow it to have nonlinear functions. That's the basis of it. All right? Why is this accurate? Why is it much better than the other ones? Well, of course, because you have a lot more nodes, you have a lot of more computing capabilities, so you will get a lot better results at the very end. All right. Now, one thing that I want to highlight is parallel computing. All these are impossible to do in a linear setting. You have to somehow break it into little pieces, run things in parallel, synthesize them at the end. Goes back to, if your computer can crunch it, it's not big data. What we need here, we need like 1,000 computers working at the same time to answer a problem in like a minute, okay? Now, big data in economics. Number one, fraud detection, whether or not, as I said, the transaction that you made was done by you or by somebody else. Customer classification, whether or not this bank client is a good one or a bad one. How would you tell? Well, you'll look at his scores, you look at some other demographics, you look at purchases and all that, you'll create a big list, but then you're going to look at other people like him, and we're talking about like thousands of folks right now, and crunch it daily, all right? Purchase suggestions, as we said in Amazon, people that bought this other one. And network of clients, that's getting traction nowadays when you're trying to figure out where does this guy fit in the general picture, in terms of income, in terms of social status, and all that. And people are interested about that. And some big data that I know that I'm getting into, health record analysis, and you'll see that getting a lot of traction in the next few years. There has been a big initiative by the US government to implement a global health record system. And that is definitely big data. For each individual, you may even have 1 or 2 gigs of data every time he goes to hospital. think about it, every MRI scan, every CAT scan, every vitals being tracked. Network of individuals. That was something that I was working on when I was at North Carolina. I was working at the Lab of Analytical Sciences, which is a collaboration between NSA and the NC State. Individuals, I put it over there in quotation marks. What we really meant is terrorist activities, all right? And how can you track things like the tweets, things like, you have boots on the ground looking at them, but you also have previous collaborations, information that comes from social media. So yes, Facebook is a little bit transparent, so be careful what you put up there. And how to connect all of that to create a network of friends, okay? Finally, gene expression correlations. What do I mean by that? You've probably heard about, big breakthroughs in genomics nowadays. What we were doing then is we had 10,000 genes and their expressions, and we're trying to figure out which 2 genes have to express for a third one to express as well. So we're talking about you have to find 10,000 choose 2 times 10,000. So these are the types of big data that we work with. Now, stock market analysis. As I said before, this is something that we finished last year. How can one get real-time stock market data and try to predict not exactly what the price is going to be? That's impossible, but at least the change in the stock movement. And we saw that that could be done. If that can now be used to gauge what the stock market is going to be, yes, we haven't done that. We haven't really proved that, but the indication is yes. Finally, topographical analysis through smart sensors. And here we heard earlier on satellite imagery. What I've heard getting some movement nowadays is using drones and how to combine the two. All right, so I'll finish up by thanking all of you guys, and especially the Lab of Analytical Sciences and Florida Polytechnic, CFAIR, and AAEA. Thank you all for your attention.